I'm Ziming from Manus. So I contribute to Manus for both the agent system and the infrastructure behind it. My background lies in like long-term building consumer-facing products and the infrastructure to support them. So Butterfly Effect is our company. We found in 2022, and in 2024, we've shifted our focus to the agent space. And in this year, March, we launched Manus. So from the moment we launched, Manus captured the global attention. Many people call it a general purpose agent because it demonstrated a remarkable performance on complex real-world tasks, expanding people's imaginations about what an AI agent could do. So during the early beta, we have to introduce a waiting list system because of the overwhelming demand. At one point, more than 2 million people were in the list. So by this August, we reported a revenue run rate of $90 million. And the latest round of funding for us is led by Benchmark. So Manus is an AI agent that can independently plan, break down, and execute tasks based on users' goals. It operates within its own computing environment. We call it Manus Computer. So where it can browse the web, write documents, run codes, or even deploy websites. After completing each task, Manus verifies its results to minimize factual errors and hallucinations. So the final output could be very rich in forms, like we have documents, images, videos, or live websites. Manus is built on two pillars. One of is the advanced model, which serves as the source of the intelligence. And Manus itself is a action engine, which provides context and the tool execution environment to the model. We activated model latent intelligence through context in engineering, shaping its behavior by our carefully designed context loops of planning, execution, and verification. So this is supported by the virtualization system and infrastructures that give each Manus task its own computing environment. And our context engineering revolves around models cache system. We believe that more tokens lead to better intelligence and better outcomes. So we leverage the cache to maintain both high responsiveness and cost efficiency, even for complex tasks. Although large models today have very huge context window, in real-world agentic problems, we also found them still insufficient. So as context window grows, the model performance decreases and the cost rise. By teaching Manus how to read from and write to files, we realized that Manus should treat file system as its ultimate context. So when we compress the active context window, we can deliver the memory to the file system. The model can still retrieve information from the files and restore it into the context as needed. Manus constantly updates and reminds itself its plans. For example, it maintains a live updating to-do files. This deliberate manipulation of model's attention ensures that all plans, all actions, and results, successes and failures alike, remain in context, allowing our agent to learn and self-correct. So Manus trades context as tokens to better intelligence. We've seen tasks that takes up to like 15,000 of iterations to finish. And all those contexts has to go to the persistency in the data infrastructure. And I'd like to talk about how we scaled Manus. When Manus launched in March, none of us anticipated the word adoption that followed. Our infrastructure simply couldn't handle the explosive growth. We had to introduce the waiting list to buy time for our engineering team to scale the system. So Manus operation depends on the preserving and the reconstruction of the large volumes of contextual data. That makes our storage has to handle massive data growth far beyond anything we had seen before. Once we rolled out paid plans and removed the waiting list, we see the data volume grew exponentially. So we estimated that by May, our storage would hit its capacity limit. That meant we had to rebuild the data system to support that, which is a massive engineering effort that could slow us down. Then we reached out to TiDB for help. So our goal was clear, to find the database system that could scale seamlessly in both compute and storage without major system rewrites. So the TiDB team joined us on site, and together, we migrated the entire Manus data system to TiDB in just 2 weeks. That was awesome. With almost no structure changes to our code. And then TiDB has continued to support us, monitoring and expanding our data infrastructure, so our engineer teams can stay focused on developing new features and driving the growth. So I'd like to share my 4 takeaways. So the first, if we could do this again, I would choose the right database at the very beginning. So we had wasted critical time and opportunities. So in that 2 weeks, we had to migrate in crisis mode. So the second one, speed has a price. We compressed months into weeks and paid it for we have to work at 2 a.m. in the midnight with our entire team debugging online with TiDB. The third is test your real workload, not benchmarks. The TPCC didn't prepare us on the production queries, and that gap cost us about 3 hours of downtime. So the fourth and the last one, we choose the hardcore approach. It can work, but only if your partners can handle it. So thanks to TiDB, the team debugged with us through the night alongside fixing issues in minutes. So that is the difference between disaster and success. Okay, the last part is our new things. It's for us, Manus never is just an AI. It's a personal cloud computing platform. Traditionally, only engineers and power users can use or harness the cloud resources for the complex and customized computing. But we believe AI could give this power to everyone. So every Manus task runs in its own virtual machine, enables users to tap into real compute capacity simply by chatting with an agent. So Manus achieved generality through visualization and opens the door to endless creative possibilities. And naturally, we began asking, what if we could expand each user's compute capacity by 100 times? And what new possibilities emerge when anyone can control a supercomputing cluster just by chatting? So that's where wide research comes in. For complex tasks, like compiling and analyzing data on the Fortune 500, Manus breaks the problem into hundreds of subtasks, each handled by a fully capable general-purpose Manus instance. These agents collaborate dynamically, combining flexibility with intelligence. And we made it possible thanks to TiDB, backed for our system. So we can only just focus on how to build a product, how to make it happen, without worrying about our data infrastructure. So we have the next step. Manus has big announcements coming, and we're proud to say it's only possible because of our partnership with TiDB. Together, we're democratizing AI, bringing supercomputer scale intelligence to everyone.